Hi everyone, welcome to Numeric Learning. In today's video, we will be solving real numbers exemplar NCERT books exercise 1.1. Okay, so usually whenever you're preparing for your exams, right? So the minute you complete a chapter, make sure you complete both the NCERT questions, all the exercise problems and the solved examples of both NCERT and exemplar. Let's start. So this is exercise 1.1. The first question is, for some integers m, every even integer is of the form. So for some integer m, okay, every even integer of the form, either is it m or m plus 1, 2m or 2m plus 1. So let us begin with understanding what are those even integers. So even integers are 2, 4, 6, 8, 10 and so on, right? Now 2 is nothing but we can write 2 as 2 multiplied by 1, correct? 4 I can write it as 2 multiplied by 2. 6 I can write it as 2 multiplied by 3. 8 I can write it as 2 multiplied by 4. So if you see, what are these 1, 2, 3 and 4? These are integers, right? These are integers m, right? These are natural numbers. So I can write 1, 2, 3, I can replace it with m, right? So it's 2m where m is 1, again 2m where m is 2, again where m is 3 and 2m where m is 4, right? Where m refers to an integer. So what are integers? You have both your positive integers and negative integers. So 1, 2, 0, 1, 2, 3, 4, everything, and minus 1, minus 2, minus 3, these are all integers. So every integer is of the form 2m. Okay, so the correct answer is C, right? You can write, therefore, every even integer is of the form, as you can see here, it's of the form 2m where m is an integer. Okay, so this is your first question of exercise 1.1. Hope you understood. Let's move on to the second question. So for some integer q, every odd integer is of the form, is it q or q plus 1 or 2q or 2q plus 1? So the same way, let's do it. What are these odd integers? Odd integers are 1, 3, 5, 7, 9 and so on. Correct? Now, how can I write 1? 1 I can write it as 2 multiplied by 0 plus 1. Okay, so 2 multiplied by 0 is 0 plus 1, which is 1. 3 I can write it as 2 multiplied by 1, which is 2 plus 1, right? 2 plus 1, which is 3. 5 I can write it as 2 into 2, 4 plus 1. Again, 7 I can write it as 2 multiplied by 3 plus 1. So here also 0, 1, 2, 3, these are all integer and the integer is denoted by q. So I can write it as, I can replace 0, 1, 2, 3 with the integer q. So 2q plus 1, right? 2q plus 1. So all of these odd integers, you can see that they are of the form 2q plus 1 where q is an integer. Okay, where q is your integer. Okay, so the correct answer is 2q plus 1. Right, now let me write a small note, okay, for all of you to understand. It will really help you. So whenever you have any number, okay, they are of two types. One is your even numbers and the other one is your odd numbers. Always remember, even numbers are of the form 2m where m is an integer, and all the odd numbers are of the form 2m plus 1. So this is very, very important. Do make a note of it. Okay, even numbers are of the form, or even integers are of the form 2m, and odd numbers or odd integers are of the form 2m plus 1. Okay, so this is extremely important. Let's move on to the third question. The question is, n square minus 1 is divisible by 8 if n is an integer or a natural number or an odd number or even number. Okay, now n square minus 1, we have to check if it is divisible by 8. Now let us try with different values of n. Okay, and let us see. So when n is equal to 1, okay, when n is equal to 1, what is n square minus 1? So you can write 1 square minus 1, which is nothing but your 0. For n equal to 2, it is nothing but your 2 square minus 1, 4 minus 1, which is 3. For n equal to 3, it's 3 square 9 minus 1, which is 8. Right? N equal to 4, again 4 square 16 minus 1, which is 15. For n equal to 5, let's stop with 5. Okay, so 5 square minus 1, 25 minus 1, which is 24. Right? Now if you see, do you think every integer, if n is an integer, that means all of these should be, so this is not the right answer, because 2, 3 is not divisible, isn't it? So not every integer is divisible by 8. So this is not the, is every natural number divisible? No. You see 3 here, you say 15, 3 and 15, they are not divisible by 8. So natural number, again, it does not satisfy. Every n as a natural number, it is not divisible. You don't see it divisible by 8. The third one, odd number. If you see odd number 1, it's 0, 3, it's 8, and 5, it's 24. So all of these are divisible by 8. Okay, these numbers are again even number, no, not divisible. So the correct answer is it's only for your odd, only for your odd integers. So 0 is divisible, 8 and 24. So it's only for these odd integers that you can see for n equal to 1, 3 and 5. You can see that n square minus 1 is divisible. Okay, it's not for all integers, but specifically only for odd integers, that is n equal to 1, 3 and 5. You see that the given expression n square minus 1 is divisible by the number 8. So that's your answer. Okay, moving on to the next question. The fourth question. The question is, if the HCF of 65 and 117 is expressible in the form of 65m minus 117, then the value of m is 4, 2, 1 or 3. You have to check it. Now first of all, let us find what is the HCF of 65 and 117 by doing prime factorization. So let's do the prime factorization of 65. You have to find the prime factorization of 65 and 117. So for 65, let's begin with 5. 5 ones are 5, 5 threes are 15 and 13 is an odd number. So this prime factorization of 65 is 3 multiplied by 13. Okay. Again 117. Let's do the prime factorization. So 3 threes are 9. 27, 3 nines are 27. Okay. So again 3, 13. So this is nothing but 3 square multiplied by 13. Right. So I'm going to add, I'll make sure the factors are common. So I'll add a 3 raised to the power 0 here and 5 raised to the power 0 here. Now the HCF of 65 and 117, we'll have to take the lowest power of the common factor. Okay, lowest power of the common factors, common prime factors. Okay, so here what is the first prime factor? Let's take 3. What's the lowest power? 3 raised to the power 0. For 5, what is the lowest power? 5 raised to the power 0. So any number raised to the power 0 is 1. And what is the other prime? It's 13. Both the cases it will be 13 raised to the power 1. So the answer is 13. But you're not asked, this is not the answer. What are you asked? If the HCF of 65 and 117 is expressible in the form of 65m minus 117, then you have to find the value of m. So this is equal to, this expression is equal to 13. Let's do it. So 65, you are given 65m minus 117 equal to 13. So 65m is equal to 117 plus 13, which will give you 0, 130, 130. Right? 65m is nothing but 130 and m is equal to 130 divided by 65, which is 2. Okay. So your m equal to 2. That's your answer. Okay. And this question is very important. It has been asked in the previous year's paper. Okay, so this question is very important. Let's move on to the next question. Yeah. The largest number which divides 75 and 125, leaving the remainder 5 and 8 respectively. So the minute you see that you have to find a number which divides 70 and 125, leaving the remainder this. So the number minus the remainder, 125 minus 8, you have to immediately, the first thing that you have to do is you have to subtract the number from the remainder. So 70 minus 5 is your first number. 125 minus 8 is your second number, whose HCF you have to find the largest number. Right? 70 minus 5 is 65. 125 minus 8 is 117. So in the previous question, we would have done the prime factorization of both. Right? So let's write that. So 65, the prime factorization is nothing but 5 multiplied by 13. 117, it is 3 square multiplied by 13. Right? If you have to find the HCF, the answer is the same as the previous question. So HCF of 65 and 117 is nothing but 13. It's the same way that you have to do, unlike the previous question. Same factorization. Okay. So the answer is 13. Let's move on to the sixth question. Yeah. If two positive integers a and b are written as a equal to x cube y square and b equal to xy cube, where x and y are prime numbers, then you have to find the HCF of a comma b. Very easy question. So let's write what is a. A is x cube into y square. What is b? X into y cube. Right? So what is the HCF of a comma b? You have to take the lowest power. Let me write it here. Take the lowest power of the common factor. So what is the lowest power of x? It is x raised to the power 1. And what is the lowest power of y? It is y square. So the HCF of a comma b is x into y square, which is option B. Okay, so it's a very easy question. Let's move on to the next question, seventh one. Yeah. So if two positive integers p and q are can be expressed as p equal to a b square and q equal to a cube b, where a and b are prime numbers, then the LCM of p and q. So let's write what is given. So p is equal to a b square, q is equal to a cube b. So your LCM of p and q will be equal to, whenever you have the LCM, you have to take the highest power of all the highest power of all factors. Okay, so what is the highest power of a? It's a cube. What is the highest power of b? It's b square. So a cube b square, the answer is C. Okay, answer is C, a cube into b square. That's your right answer. Let's move on to the last question, the eighth question. Yeah, the product of a non-zero rational and an irrational number is it always irrational, always rational, rational or irrational, and 1. So suppose you have a non-zero rational number, say for example 2. You have to find the product multiplied by an irrational number, which is root 3. So 2 is your rational number and your root 3 happens to be your irrational number. So when you see the product, it is, what is 2 root 3? 2 root 3 is also irrational. Okay, so always remember the product of a non-zero rational and an irrational number is always irrational. Okay, so this is something which you have to note. And let's go on to the next question. The least number that is divisible by all the numbers from 1 to 10 both inclusive is, what is the least number that is divisible by all the numbers? You have to find the LCM. Okay, LCM of all the numbers from 1 to 10. So whenever you have to take the LCM, what do? You have to take the highest power of all prime numbers. Okay, you have to take the highest power of all prime numbers. So for 1 is not a prime number. Okay, so we are not writing 1. 2 is the first prime number. So 2. What are the prime factors of 2, or when you factorize? It's just 2. 3 is a prime number, as such 3. 4, when you prime factorize it, you get 2 square. 5, again 5. 6, I can write it as a product of 2 into 3. 7, again a prime number. 8, I can write it as 2 cube. 9, I can write it as 3 square. And 10, I can write it as 2 multiplied by 5. Okay. Now, if you see here, your LCM, okay, LCM of all the numbers 1 to 10 will be equal to, take the highest power. For 2, what is the highest power? It's 2. Is it 2 square? See, look here. You have a 2, 2 square, 2, 2 cube and 2. So what is the highest power? It is 2 cube. So 2 cube multiplied by, what is the highest power of 3? So you have a 3, 3, 3 square. So the highest power of 3 as a prime factor. What is the highest power of 3? It's 3 square. For 5, there is just a 5. Is there a 7? Yes, there is a 7. That's all. This is the LCM. So what is 2 cube? 8 multiplied by 9 multiplied by 5 multiplied by 7. Right? 8 5s are 40. So 40 multiplied by 9 multiplied by 7. 4 9s are 36. 360 multiplied by 7. So your answer is 2520 is the LCM. So the answer is D, 2520. Always remember, whenever you have to take the HCF, you have to take the lowest power of the common factor. If you have to take the LCM, you have to take the highest power of all the prime factors. Okay, so with this, we are we have solved all the questions of exercise 1.1 of your NCERT Exemplar. Please do try it. And if you have any doubts, please do post it in the comment and I will make sure I answer it in the next video. Happy learning. Please do share it with your friends if it was useful, and please do not forget to subscribe and support. Thank you.